Ground fault circuit interrupters, or GFCIs, are crucial safety devices designed to protect against electrical shock. They work by monitoring the current flowing through hot and neutral wires. If a difference in current is detected, indicating a potential ground fault, the GFCI trips, cutting off the power almost instantly. This prevents dangerous electrocution. However, testing GFCIs, especially in older homes without ground wires, can be challenging. A typical test button on a GFCI tester may not function as expected in a two-wire Romex system because the tester relies on a ground path to complete the circuit. In these situations, you'll need to simulate a ground fault to verify the GFCI's functionality. One method is to create a temporary bootleg ground, but this should only be done by a qualified electrician. This involves connecting a wire from the green grounding screw in the outlet to a grounded metal conduit or electrical box. With the temporary ground in place, push the test button on the GFCI. If the GFCI trips, it indicates it is functioning correctly. Remember to remove the temporary ground connection immediately after the test. If the GFCI doesn't trip, it suggests a problem. There are several potential reasons why a GFCI might fail. Firstly, the GFCI receptacle or breaker itself could be faulty. Like any electrical component, GFCIs can wear out or fail over time. Secondly, loose or damaged wiring connections can prevent the GFCI from working correctly. Poor connections can disrupt the current flow and interfere with the GFCI's ability to detect ground faults. Thirdly, an overloaded circuit might cause a GFCI to malfunction. When a circuit is overloaded, it can create imbalances that affect the GFCI's operation. It is crucial to regularly test GFCIs, especially after any electrical work or modifications. If a GFCI fails to trip when the test button is pressed, it should be replaced as soon as possible to ensure safety. When inspecting homes, recommend installing GFCIs in critical areas like bathrooms, kitchens, and outdoor locations, even if they are absent. These areas are prone to moisture and water exposure, increasing the risk of electrical shock. Always advise homeowners to contact a qualified electrician for comprehensive electrical inspections and to ensure the proper functioning of all circuits and safety devices. For those encountering GFCIs with only test and reset buttons working without tripping during testing, it could signify a compromised or incorrectly installed device. The absence of a ground wire in older homes complicates the matter, as GFCIs rely on this ground to function correctly. When a GFCI doesn't trip, it could be due to several issues. Firstly, the GFCI may not be properly grounded, especially in older homes with two-wire systems. Without a solid ground connection, the GFCI cannot effectively detect and respond to ground faults. Secondly, there might be wiring problems within the circuit, such as loose connections, damaged wires, or incorrect wiring. These issues can disrupt the GFCI's ability to function correctly. Thirdly, the GFCI device itself could be defective. Like any electronic component, GFCIs can fail over time or be faulty from the start. Fourthly, improper installation can also cause GFCIs to malfunction. If the GFCI is not installed correctly, it may not be able to detect and respond to ground faults effectively. To properly assess the functionality of GFCIs in older homes, firstly, visually inspect the wiring and connections to ensure everything is secure and in good condition. Look for any signs of damage, such as frayed wires or loose connections. Secondly, use a GFCI tester that simulates a ground fault. Plug the tester into the outlet and press the test button to see if the GFCI trips. If it doesn't trip, it indicates a problem. Thirdly, if possible, consult with a qualified electrician to evaluate the wiring and grounding system. They can identify any underlying issues that may be causing the GFCI to malfunction. Fourthly, consider upgrading the wiring system to include a ground wire, especially in critical areas like bathrooms and kitchens. This will ensure that GFCIs can function correctly and provide adequate protection. Fifthly, replace any faulty GFCIs with new ones that are properly grounded and installed. This will help to ensure the safety of the electrical system. Finally, educate homeowners about the importance of GFCIs and how to test them regularly. This will help them to identify potential problems early on and take appropriate action. In summary, testing GFCIs in older homes without ground wires requires careful consideration. If a GFCI fails to trip, it could be due to grounding issues, wiring problems, a defective device, or improper installation. Consulting with a qualified electrician is essential to properly assess the situation and take appropriate action to ensure electrical safety. In newer homes where GFCIs on grounded systems do not trip, even with working test and reset buttons, it also points to potential issues. Firstly, verify the integrity of the ground connection. A loose or faulty ground wire can prevent the GFCI from functioning correctly. Use a multimeter to test the resistance between the ground pin of the outlet and the known good ground, such as a metal water pipe. The resistance should be very low, ideally close to 0 ohms. Secondly, inspect the wiring connections at the GFCI receptacle. Ensure that all wires are securely connected to the correct terminals. Loose or corroded connections can disrupt the flow of current and prevent the GFCI from tripping. Thirdly, use a GFCI tester to simulate the ground fault. Plug the tester into the outlet and press the test button. If the GFCI still doesn't trip, it indicates a problem with the device itself or the wiring. Fourthly, check for any potential sources of leakage current in the circuit. Leakage current can interfere with the GFCI's ability to detect ground faults. Use a clamp meter to measure the current flowing through the circuit's ground wire. If there is excessive leakage current, identify and address the source. Fifthly, consider the possibility of a multi-wire branch circuit. These circuits share a neutral wire, which can sometimes cause GFCIs to malfunction. If you suspect a multi-wire branch circuit, consult with a qualified electrician to evaluate the wiring. Sixthly, if the GFCI is part of a combination of PSI/GFCI breaker, test both the GFCI and PSI functions separately. A problem with one function may affect the other. Use the test buttons on the breaker to verify that both functions are working correctly. Seventhly, ensure that the GFCI is properly rated for the circuit. Using a GFCI with an incorrect amperage or voltage rating can cause it to malfunction. Check the GFCI's specifications to ensure they match the circuit requirements. Finally, if all other troubleshooting steps fail, replace the GFCI with a new one. It is possible that the existing GFCI is simply defective. When replacing the GFCI, ensure that it is properly grounded and wired according to the manufacturer's instructions. In addition, always use a calibrated tester. If the device isn't calibrated, it could cause issues in testing the device as well. In summary, if a GFCI on a grounded system doesn't trip when tested, it's crucial to investigate the ground connection, wiring, leakage current, and the GFCI device itself. Consulting with a qualified electrician is essential to accurately diagnose and resolve the problem. Remember, GFCIs are essential safety devices, and their proper function should never be compromised.